So welcome everyone to the live interactive session number 7 for the course Mechanics of Fiber Reinforced Polymer Composite Structure. Today I am going to discuss some sample problems related to assignment number 7 and I am a TA. My name is Aranya Mandal. So let's start with the questions. So the first question is, in an orthotropic lamina, the direction dependent properties could be controlled by, the options are A, selecting fibers with appropriate strength, selecting matrix with appropriate strength, or C, selecting different fiber orientation, or D, all of these. So whenever you are making a lamina, using a lamina and combining it to form a laminate, then we have to consider all about the fiber, the matrix, and also in which direction the orientation of the fibers are, as according to the orientation of fiber, it gives the strength in different axes. So in an orthotropic lamina, the direction dependent properties could be controlled or tailor made by changing types of fiber matrix, and for a given fiber matrix combination by changing fiber orientation and fiber volume fraction. So any lamina, you can change, tailor made is conditions depending on what type of fiber you are using, what type of matrix you are using, and also in which angle the fibers are aligned in the matrix, and also most important, the fiber volume fraction. So these four properties are what you can depends on how you are manufacturing the lamina, or what different fiber matrix you are considering. Accordingly, you can tailor make the properties of a orthotropic lamina. So as asked in the question, which for an orthotropic lamina, which of the properties will be controlled? So all of these properties along with the fiber volume fraction are these four properties which when controlled can give us if a lamina according to our requirement. So question number 2 is that a lamina with thickness 0.1 mm has a longitudinal tensile strength sigma T1U, that is the ultimate tensile strength in longitudinal direction, as 1500 megapascal. The width of the lamina in meter required to withstand tensile load of 150 kilonewton in longitudinal direction is. So to find the tensile load, the equation is equal to tensile strength into the area. So the tensile strength is given to us, that is 150 kilonewton. So we will write in terms of the unit Newton is equal to tensile strength. The tensile strength is 1500 megapascal. We will write it in terms of Pascal, that is 10 to the power 6 into the area. So the thickness is given 0.1 mm. So we will convert it into meter, that is zero point 0.1 into 10 to the power minus 3, and the width. So width is what is not known to us. We have to find out. So area here is the cross section area in this this side. The thickness and the width will give us the area as that strength is applied in this direction, the direction 1. So we will take this cross section area. So we know the thickness and this width is not known. We will put that in this equation, and from that we will get the value of the width in, as they asked, in meter. So by converting all the units properly, we can get the final width in meter, that is 1 meter. Next question, question number 3 is that in a lamina, the transverse stiffness and transverse strengths are. The options are A, dominantly decided by matrix properties, B, dominantly decided by fiber properties, C, equally decided by fiber and matrix properties, or D, independent of matrix properties. So whenever we are talking about transverse and longitudinal, so longitudinal is the direction in which the fibers are aligned. Now, as you can see in this diagram, these fibers are aligned at an angle theta, and the alignment of this fiber will give us the longitudinal direction, which is different from the global axis. So global axis is this x and y, and the direction in which the fiber is aligned will give us the material axis, and the fiber direction is known as the longitudinal direction. Now, when you are stretching something in the longitudinal direction, the most force will be applied on the fiber. But when you are applying it in the transverse direction, then the fibers are not aligned parallel to the transverse direction. So most of the load will be on the matrix, because the matrix is the one which is binding all the fibers to each other. So when we are going in the transverse direction, there is no direct alignment of the fibers. So the most of the property that will be dominant at that point will be the matrix. So here the transverse stiffness and transverse strengths are dominantly decided by the matrix properties. Next question is question number 4, that strength and stiffness of a laminate are, option A, decided only by the strength and stiffness of the constituent lamina in the laminate. B, decided by both stacking sequence of the laminate and the strength and stiffness of the constituent lamina. C, independent of strength and stiffness of constituent lamina, or D, independent of stacking sequence of the laminate. So we are talking about the whole laminate. That is, when we are considering a single lamina, that time, as the first question said, we consider the fiber, the matrix, the volume fraction, and the angle in which they are aligned. Then comes the laminate, which is by stocking different laminas. So when you are stocking different laminas, if suppose you are stocking all the laminas in only zero angle, then it will have a uniform strength, longitudinal and transverse strength. But when you will add up different angles to it, then it will have more. Suppose you are using zero lamina for many stacks, like 5 zero lamina, you are making a laminate. So in longitudinal there will be high strength, but in transverse there will be low. But if you use a angled one like 45-degree in middle, then there will be some force toward there will be higher force toward the transverse also. So the stacking sequence according to our application and requirement is also important, which will like distribute the strength throughout this laminate. That's why stocking sequence with different angle laminates is also very important. So option B will be the answer, that the strength and stiffness of a laminate is decided by both stocking sequence of laminate and the strength and stiffness of constituent laminate. Next question, question number 5, that which of the following is a correct unit of force resulted in classical lamination theory? So when we are talking about force resultant, so the force resultant is equal to force per unit width. So as we already know the unit of force, that is Newton, and when we talk about force resultant, it will be force per unit width, so that will be Newton per minute. So that will be the unit of force resultant. And which of the following is a correct unit of moment resultant in a classical laminate theory? So again, like force resultant, moment resultant, whenever the word resultant will come, it is the moment per unit width. So the unit of moment we know Newton into meter, and with respect to unit width, we will divide it by meter, it will be Newton. So the unit of moment resultant will be Newton. The next question is question number 7. The two laminates with identical dimensions are made from same glass epoxy laminate with same lamina thickness, both with stocking sequence 09090 and 900090 are subjected to same axial load, tensile load. Which of the following is true? So the options are A, mid surface strain in 09090 will be equal to those of 900090. Option B, mid strain surface strains in 09090 will be higher than those in 900090. Option C, mid surface strain in 09090 will be lower than those in 90090, or mid strain in both laminates will be 0. So mid surface strain, talking about the strain that will be at the middle of the whole laminate. So the middle point of the laminate, if we consider for 09090 will be 090, then the midpoint, then 90. Similarly for 90090 it will be 90, then the mid surface, then 090. So in both these cases, you see above or below the mid surface, it is one lamina of 0 and one lamina of 90. So in whatever combination these are, either it is 090 or 90, the total axial load by that laminate made by these two lamina will be same. So that is why mid surface strains in both of this sequence will be equal, because above and below the mid surface strains it's single 0 and 90, and when you combine a 090 and form a laminate, the strengths will be same above and below the mid surface. Therefore, option A will be correct, that the mid surface strains in both these sequences will be equal. Now, before moving forward with the questions, some theory that I wanted to first discuss, and after that I will go back to the question. So, it is already taught in the videos about CLT, sir has taught, but these are some notes from the fiber reinforced composite book by P.K. Malik. So, in this, if you read these notes, that this will be like directly you can be able to answer some of the questions that are given in the assignments that I will be discussing later. So here you can see in this figure the laminate geometry. So this is the laminate geometry according to what we considered, we study the CLT. How we consider this is the whole laminate. We take the mid plane, and according to that we give the naming, that for what the height of, suppose the jth lamina, the thickness is TF, and the height from the mid plane will be H j minus 1 and Hj. So this diagram shows that whenever we are considering a laminate, always we take the mid plane and as the 0 point, and with that 0, considering the 0 point, we will go up and down with the what is the thickness of that thickness and the location of that lamina in that laminate. So this laminate geometry shows that. Now the strain uh, for that whole laminate will be equal to the strain at the mid plane normal strains, plus Z, which is the distance from the mid plane in the thickness direction, multiplied by the bending curvature of the laminate. So this is the equations for mid plane, for the normal strains and the shear strains for this whole laminate. Now this equation contains two components, that is one mid plane strains and the another is the what will be the curvature and the location of that lamina. So that will give you the total strain of the laminate. Now the laminate forces and moments, the applied force and moment resultant on a laminate are related to the mid-plane strains and curvature by the following equations. So these are the equations which relates the mid-plane strains and curvature to the force and momentum resultant. So from this equation came these two matrix notations. So in this matrix notation, you can see the first one, which is nxx, nyy, nxy. So these are the force resultant. So force resultant is equal to the A matrix into the midplane strains plus B matrix into the curvature. Similarly, the moment resultant is equal to the B matrix into the midplane strain plus D matrix and the your bending curvature. So here nxx, nyy are the normal force resultant in x or y direction per unit width. Nxy is the shear force resulted per unit width. Mxx, myy are bending moment resulted in x, yz and xz plane per unit width, and mxy is the twisting moment torsion resulted per unit width. Now in these two equations, this ABBD matrix. So the A matrix is called the extensional stiffness matrix for the laminate, whose units is Newton per minute or pound per inch. And this A matrix can be written like this. The B matrix is the coupling stiffness matrix for the laminate, whose unit is in Newton or pound. And D matrix is the bending stiffness matrix for the laminate, whose unit is in Newton meter. So these are the three matrices that are used which, for defining the whole laminate stress and strain. Now, there are some observations from this from the components of this ABD matrix, such as that A16 and A26 couple in plane normal forces to mid plane shear strain and in plane shear force to mid plane normal strain. So A16 and A26. You see in this equation A16, A26, and also here. So it will couple in plane normal forces to mid plane shear strain. So this is the normal force and this is the shear strain. Similarly, it will add in-plane shear force to mid-plane normal strain. So this is the in-plane shear force and these are the normal strains. So this A16 and E26 gives us a relation between these two things. Then B11, B12 and B22 couple in-plane normal forces to bending curvatures and bending moments to mid-plane normal strains. B16, B26 couple in-plane normal forces to twisting curvature and twisting moment to mid-plane normal strains. B66 couples in-plane shear force to twisting curvature and twisting moment to mid-plane strains. And D16, D26 couple bending moments to twisting curvature and twisting moment to bending curvature. So these are the few components of the matrix which gives us the different relations between either it is shear strain and the either the shear strain, the normal strain, or the curvature and the twisting. So all these different conditions, the like twisting, bending, the shear and the force, shear force and the normal force, these four conditions. So these all coefficients gives us a relation between which force and which shear is depending on which bending or twisting, depending on which coefficient. So that is what is explained. These are some observations from those matrices. Now this ABD matrix, how they are formed? So the elements in stiffness matrix, the elements in ABD matrix are calculated from these equations. So this is the equation that is used for finding the whole A matrix. So here the Q, M, N, J. So Q is the reduced stiffness matrix of any one lamina and then multiplied by the location of that lamina and such and from that you have to sum up all the laminas. So you need the stiffness matrix, reduced stiffness matrix of that lamina, the location of that lamina, and from that you can form the whole A matrix. Similarly for B matrix, the equation is half into the summation of reduced Q matrix into Hj square minus Hj minus 1 square. So this H is shows the location of that lamina, and from that location which you are taking from the midpoint, that you have to do square of it. And similarly, the D matrix here it is 1 by 3 summation of Q matrix into H cube J minus H cube J minus 1. So N is the total number of laminas in the laminate. The Q is the elements in the Q matrix of the jth lamina. Hj1 is the distance from the midplane to the top of the jth lamina, and Hj is the distance from the midplane to the bottom of the jth lamina. Now the element. The elements of the stiffness matrices A, B, D are functions of the elastic property of each lamina and its location with respect to the midplane of the laminate that just I told. So these are some of the following observations are important regarding this stiffness matrix. So from these observations, you will be able to solve few of the questions that I will be discussing next. So the first observation is that if B is a non-zero matrix, a normal force such as Nx will create extension and shear deformation as well as bending, twisting, curvatures. Similarly, a bending moment such as Mx will create bending and twisting curvature as well as extension, shear deformation. Such extension bending coupling represented by the B matrix is unique in laminate structure regardless of whether the layers are isotropic or orthotropic. So B matrix, if it is non-zero, you can see the B matrix is relating the force, resultant force to the bending and also the moment to the mid-plane strain. So it is B matrix is like the relation which attaches all the forces, the shear force, the and the strains and the moment and the curvature, all of them. So if B is a non-zero matrix, all of them are correlated to each other. Then comes the observation 2 that for a symmetric laminate, the B matrix will be equal to 0 and there is no extension bending coupling. To construct a symmetric laminate, where every lamina of plus theta orientation above the midplane must be matched with an identical in thickness and material lamina of plus theta orientation at the same distance below the midplane. So, what constitutes symmetric laminate? Symmetric laminate will be one in which the after midplane at a similar distance from the midplane, there should be a lamina which will have the angle plus theta, and at the same distance from the midplane, there should be another one below the midplane with the same angle plus theta. At that time, you can say the whole laminate is a symmetric laminate, and for a symmetric laminate, the matrix will be equal to 0. Next is if for every lamina of plus theta orientation, there is an identical equal in thickness and material lamina of minus theta orientation, the normal stress strain coupling, stress shear strain coupling represented by A16 and A26 in the A matrix for the laminate is 0. The locations of these two laminas are arbitrary. Such a laminate is called balanced laminate. For example, here 0 plus 30 minus 30 plus 30 minus 30 and 0 is a balanced laminate for which A16, A26 will be equal to 0. Note that with proper positioning of layers, it is possible to prepare a balanced symmetric laminate. For example, 0 plus 30 minus 30 minus 30 plus 30 is 0 is a balanced symmetric laminate for which A16, A26 is 0 as well as B is 0. So this one, when you are taking this condition, you can see it is both balanced as well as symmetric. So when we are coming to the point of symmetry, B matrix will be equal to 0, and when it is a balanced laminate, A16, A26 will be equal to 0. And a balanced laminate is one which will have both the plus and minus orientation together and they will have the same thickness. At that time, it will become a balanced laminate. Condition 4 is that if for every lamina of plus theta orientation above the midplane, there is an identical lamina in thickness and material of minus theta orientation at the same distance below the midplane, the bending moment twisting curvature coupling represented by D16 and D26 in the D matrix for the laminate is 0. For example, for a 0 plus 30 minus 30 plus 30 minus 30 0 laminate, D16 D26 is equal to 0. Note that the D16 D26 terms cannot be 0 for a symmetric laminate unless theta is equal to 0 and 90. So you have to remember this condition. D16 and D26 cannot be 0 for all the symmetric laminate unless the theta is equal to 90 and 0. Now 90 and 0, for 90 and 0, there will be another type of laminate known as cross-ply laminates. So cross-ply laminates are those in which the laminas are attached as 090, 090 like that. So those are cross-ply. So if it is a cross-ply, then again D16 and D26 will be 0. Otherwise, if it is symmetric laminate, then it won't be 0. Now let's come to the question. So question number 8 is that in a symmetric laminate, so which of the options will be correct? So option A is that all the elements of B matrix are 0. B, only B16 and B26 are 0. Option C, all the elements of D matrix are 0. Or option D, only D16, D26 are 0. So as I discussed before, this observation number 2, that for a symmetric laminate B matrix will be equal to 0, and that D16 and D26 cannot be 0 for a symmetric laminate. So from these 2 points you can answer here that option D will not be correct and option B and C will also not be correct. So the correct option will be option A, that all the elements of B matrix will be 0 for a symmetric laminate. Next is in a cross-ply symmetric laminate 090s, which of the following is correct? Now it is a cross-ply, it is a symmetric laminate, so all the elements of B will be 0. Now in the last option they said that D16, D26 will be 0 only when theta is equal to 0 and 90. So here theta is equal to 0 and 90. So D16 and D26 will also be 0. The B matrix is called coupling stiffness matrix of the laminate. Okay, so in a cross ply, here you got that the B option C will be correct, as it is a symmetric matrix. B will be the B matrix whole will be 0. D16, D26 will also be 0, and A16, A26 will also be 0. As here the point comes, if it is a balanced matrix, uh, then A16 and A26 will be 0. But now 0 plus or 0 minus means the same thing. Similarly, 90 plus or 90 minus will give you the same thing. So it will also act as a balanced matrix. That's why A16 and A26 will also be 0. So all of these will be the condition for a cross-ply symmetric laminate 090 symmetry. In a balanced symmetric laminate, for example, plus 45 minus 45 symmetric, which will be the answer. So as we already discussed, for a balanced symmetric laminate, A16 and A26 will be equal to 0 and all the other things will be non-zero. And B matrix will also be 0 because it is a symmetric matrix. Now the last question is, a 2.4 mm thick laminate when subjected to in-plane loads experiences mid-surface strains and curvatures as follows. So the mid surface strains are given and the curvatures are given. So it is to be noted that Z is measured from mid-surface and is negative towards top surface. The global strains epsilon x, epsilon y and gamma xy in micrometer per meter at the bottom and top surface of the laminate respectively are. So we have to find the global strains and the mid-plane strains and the curvatures are given. So we already know this equation. How to find the global strain? So global strain is equal to the mid-plane strains plus the location, the thickness into the curvature. So here we took the laminate thickness as 2.4. So we will take the midpoint of 2.4. So above and below the thickness will be 1.2, and we are considering, it is given in the question that towards the surface it is negative. So above this will be negative, that is minus 1.2 mm, and below will be positive 1.2 mm. The total thickness of laminate is 2.4 mm. At the bottom of the laminate, where the height will be equal to plus 1.2, we use this equation. So we know a value of epsilon, the mid surface trace, plus the location, that will be plus 1.2 mm. So we will transform the all the units you have to convert in the basic units. So in meter into 10 to the power minus 3 multiplied by the curvatures value. So you will get the strain. This will be the strain at the bottom. So at the top of the laminate, here again the H value you have to take a negative and you will get the global strain on the top of the surface. So from that you can choose which option will be correct. So option B is the correct one, which is giving, like will give the value, both of these values here. So you will get the strain at the top and bottom of this laminate. Okay, so any doubts? Any doubts in the sample questions that I just discussed, or anything, or the notes?
मैम जो असाइनमेंट अभी गिवन है हमें,
Huh?
मैम जो असाइनमेंट नंबर 7 हमें गिवन है ना अभी,
Huh?
मैम उसमें क्वेश्चन नंबर 7 एंड 8 समझ नहीं आया।
अ, अ, जो असाइनमेंट गिवन है उसका मैं नहीं समझा सकती, वो तुम्हें खुद से सॉर्ट आउट करना पड़ेगा। ये जो सैम्पल प्रॉब्लम है इसी से तुम्हें आइडिया लेना होगा, और जो सर ने क्लास में कराया उसी से। जो करंट असाइनमेंट है वो मैं सॉल्व करने में हेल्प नहीं कर सकती, वो तुम्हें खुद से सॉल्व करना होगा। बट क्या क्वेश्चन है तुम बताओ, मे बी अगर सैम्पल क्वेश्चन से रिलेटेड होगा देन आई माइट बी एबल टू हेल्प। क्वेश्चंस क्या है?
यस मैम, क्वेश्चन सैंपल सही है मैम, जो बैलेंस्ड, एक 1 मिनट मैम, क्वेश्चन नंबर 7 है मैम, इन अ बैलेंस्ड सिमेट्रिक लैमिनेट, और मैम
हम्म।
इसमें आया था कि जो बी मैट्रिक्स होता है वो 0 होता है, मतलब जो कपलिंग मैट्रिक्स है। बट
हाँ।
मैम इसे मैं ये नहीं पता ना कौन सा कपलिंग है, मतलब शेयर एक्सटेंशन कपलिंग है कि एक्सटेंशन एक्सटेंशन कपलिंग है, ये समझ नहीं आया।
ऑप्शंस में क्या है, बी मैट्रिक्स बोला या फिर बी मैट्रिक्स का नाम
मैम
लिखा?
ऑप्शन में मैम ऐसे ही दिया है, मैं ऑप्शन में शेयर एक्सटेंशन कपलिंग टर्म्स आर नॉन जीरो, शेयर एक्सटेंशन कपलिंग टर्म्स आर जीरो, एक्सटेंशन एक्सटेंशन कपलिंग टर्म्स आर जीरो, और नन ऑफ द अबव। मैम वो कौन सा कपलिंग है समझ नहीं आया, वो जीरो जो था बी वाला।
ऑप्शंस बताना एक बार।
यस मैम, 1 मिनट।
या फिर कॉपी पेस्ट करके इस मैसेज में लिख दो।
यस मैम, डन।
ओके, शेयर एक्सटेंशन का प्रिंटर। जो भी शेयर, जो भी तुम्हारा फोर्सेस होगा ना, फोर्सेस और फोर्सेस टर्म अगर एक दूसरे से कनेक्टेड हो तो उसको एक्सटेंशन बोला जाता है। और जब अगर किसी के फोर्स वाला टर्म अगर शेयर के साथ मतलब कंपेयर किया जाता है, तो वहां पे शेयर और एक्सटेंशन कपलिंग होता है। तो उस हिसाब से अगर देखा जाए तो एक्सटेंशन एक्सटेंशन कपलिंग टर्म्स आर जीरो। तुम्हारे बैलेंस में होना चाहिए, A16 A26 इक्वल टू 0 होगा, और A16 A26 तुम्हारा couples in plane normal forces to mid plane shear strain and in plane shear force to mid plane normal strain. So ये shear और extension coupling कर रहा है। तो shear और extension coupling जहाँ पे होगा आर जीरो वो बैलेंस सिमेट्रिक होगा. सो ऑप्शन जो बी है यहाँ पे देखना शेयर और एक्सटेंशन कपलिंग बिकॉज A16 A26 तुम्हारा जीरो होना चाहिए. सॉरी, A16 and A26 are supposed to be zero. So A16 and A26 are those which combines your force terms with the shear terms. So that means option B, which they are talking the shear term and extension coupling terms are zero. So I think B option will be the correct one. That this is zero. So A16 and A26 they join your the force term with the shear term. So this force term are called the extension terms and shear terms are the shear terms. So option B is the only one which is saying that the coefficient which relates the extension and the shear terms are equal to zero. So option B will be the correct one. And for okay, uh, Anuj,
Yes, ma'am. Yes, ma'am.
and the laminate is talking sequence. So here you can see if the first thing whenever you have to understand what type of lamina it is. So whenever you have to understand the laminate, first thing is to divide it into half. So here if you divide the upper part and lower part, okay, then you will see above it is 30 minus 45, 45. Again in that same rotation, like if 45 is the last one, then it will start from 45 minus 45, 30. So obviously you can see it is a case of symmetry. Symmetric laminate is there. Now the question is to see if it cross ply laminate or not. So as I defined in the what is the definition of cross ply laminate? It should have 090 090 like that. If there is 090 alternate to each other, that will make a cross ply laminate. But here you are getting different angles. This is not a cross ply laminate. And a balanced laminate will have both positive and negative of it. But here for 30 there is no negative 30. So it won't be a balanced laminate. So this will be an example of symmetric laminate. Okay. First, the most easiest thing is to find whether there is a symmetry or not. Once you cross that, then you have to think whether it is balanced or cross ply or the angled one. So here you can see it is easily you can see that you can be symmetric. So symmetric laminate.
मैम बैलेंस्ड का एक बार और बता दीजिए बैलेंस्ड लेमिनेट का.
Uh, yeah, definition है. If for every lamina of plus theta orientation, see here in the definition you can they are saying every lamina. So in the question that is you just showed, there you can see for 45 there is positive and negative, but for 30 there is only positive 30. So it is said that if for every lamina of plus 30 plus theta orientation there is an identical equal in thickness and material lamina of minus theta orientation, that time it will known as the balanced matrix, balanced lamina. So if they like in the question that you have shown 45 positive, negative was also there, but for 30 positive there was no negative 30. So that's why it won't be a balanced one. So for balance, every positive theta should have a negative theta. Then that will form a balanced laminate. Uh, was it clear?
Yes, ma'am.
Ma'am, for cross play, how it should be, ma'am? For cross play laminate, how it should
Cross
be?
ply, it should be 090
090.
090 like.
090, 090.
You can read all this types of lamina and all my notes are from this PK Malik book, the fiber reinforced composite. So it will like help you to clarify it directly. Or you can see the PPT. I put all those pages from the book.
Okay, ma'am.
Anything else? Any more doubts? Hari, do you have any doubts in this assignment?
Yeah, ma'am. Just a minute. I can just a minute.
Okay.
Ma'am, here the first statement is correct. The laminate is very thin layer of fibers included into matrix. Am I right?
Yes.
But in next term, everything okay, man. But in last line, I have seen by changing the fiber orientation, the fiber volume fraction, the, it was dependent. It was direction dependent, ma'am. In orthographic lamina, uh, the, for a given fiber and matrix combination, it was depends upon the directions. It will
Huh.
be change the fiber orientation.
And fiber,
The
yeah, it is
fiber
correct.
orientation okay, but what about the fiber volume for fraction, ma'am? It was also
Uh,
called volume of fraction. The
for
volume
direction,
of fraction.
like fiber volume fraction talks about the whole lamina, like the whole properties of the lamina. So if the fiber volume fraction is higher, that means the fiber's properties will be more, and fiber has gives you more like longitudinal strength and everything. So accordingly, fiber volume fraction, if it is higher, then strength will be higher because matrix has lower strength than
Yes.
fiber. So if the fiber is more, then it will overpower the overall composite condition will be higher.
The
So that's why fiber volume
totally
fraction is there.
the properties it will be controlled by the fiber orientation. Am I right, ma'am? In a matrix, the fiber orientation will control the entire properties, right?
Orientation will control. So are you getting confused about the direction point, like direction dependent property only? Because
No, ma'am, I'm
direction
very clear
dependent.
about direction dependent. Yes. Yeah, ma'am,
So
tell me.
if both these points, that fiber orientation and fiber volume fraction, they are defining the property, right? Then
Yes.
why you're having? I didn't understand your doubt. Sorry. Is it a question? Like, uh, from what
No, no,
point
ma'am.
you're?
Actually, it is an no, ma'am. It is an the statement true or false like that. That's what the first statement is true. I'm very clear. But in terms of second statement, the last line they have mentioned is the, the dependent property should be controlled by changing the fiber orientation. That's what my doubt. But now understand. Orientation will
The
control the.
statement is correct.
Yeah, second statement also correct, ma'am.
Yes. It is already. It's from Sir's notes only. You can see I also copy pasted
Yes,
here.
yes,
So in
yes.
your orthographic lamina, dash should be control the element by changing fiber matrix, and for a given fiber matrix combination by changing
No,
fiber orientation, fiber volume. So it will be correct.
yeah, yeah, ma'am. Thank you. Ma'am, one more statement is there. Shall I post it?
Okay. You can post.
First one, in terms of strength and stiffness, the laminate depend only on the stackle sequence. The laminate and do not depends upon the strength and stiffness of the construct lamina. No, ma'am, first one is wrong. What I'm saying, the strength and depends upon laminates and the construct laminates. Am I right?
it will depend on both
Yes, ma'am.
strength
The
and
first statement
stiffness.
is wrong, right?
Like the third point that you gave is wrong. That not only strength and stiffness of lamina depend not only on
No, ma'am.
static stiffness of
First
lamina but
strength,
also.
strength is divided on a slabbing sequence, and
Okay.
also by the constant lamina. I mean, sir, also first statement showed this one. Uh,
This first one, the strength and stiffness of laminate depend only on stacking sequence of laminate is wrong. This one is
I,
wrong.
no, ma'am, that is right, ma'am.
Then the
Yeah,
second
first
one,
one is right, wrong. First, ma'am, in first term, first part is right, second part is wrong. Am I right, ma'am?
strength and stiffness of
Strength and stiffness of a laminate depends upon slagging sequence and constant lamina. But here they are saying it was not depends upon the
no, this
stiffness
is
of the
also wrong.
constant lamina.
Uh,
Yeah, yeah,
See, because laminate, when they are talking about a laminate, you have to consider about the laminas. So it will be
yeah,
both the
ma'am.
strength of different lamina and also their alignment. So the whole statement that will be correct is that one, that it will depend on both. So anything else, any other statement is wrong.
Yeah, ma'am. So the first one is wrong, ma'am.
So this
Strength and
one,
civil lamina depends upon. First one is wrong, ma'am. The second one is the strength and stamina depends upon each
this is
sequence
also
of
wrong.
matrix, and
This
do
one is
not
the
depends
correct
upon.
one, third one.
No, first is both to them. Third one only correct. No, strength and stamina
Huh,
depends
third one is only correct.
depends not only on slag limit, but also strength and yeah, first two wrong, ma'am. Third one only correct. Ma'am. Yeah, ma'am. Thank you.
Yeah. Class.
I mean, in cross play, I have said 0, 90 and 90 0. I am right, ma'am.
Um, it should be like 090, 090, not zero
Correct.
ninety
0, 90
90.
0, 90, ma'am.
Huh.
Okay, no. But in assignment question, I have seen it 090, which is following is correct. They are asking on sequence based. It is a question cross fill lamina 090. Which of the following statement is correct? As with 090, 090 means
It
A
is 090 only.
option
It
the
is,
first
if it
option
is
A
not,
only, ma'am. A 16.
sir, it is a cross ply. So I'll just explain that. For cross ply, A16, A26 will be 0, D16, D26 will be 0, and D matrix will also be 0. But it is
Sorry,
not
A1
symmetric. It
6 A
is
2.
so A16, A26, and D12, D26 will be 0 because as it is not a
Ma'am, it is a
symmetric one,
it is a cross play. Ma'am, it is a cross play laminate, ma'am.
it is a cross ply
We are
laminate.
talking about.
I am talking about cross ply laminate. Option A is the correct.
Ma'am, we have. Okay, okay. Okay, ma'am. Then clear, ma'am. No problem. Thank you, ma'am. Ma'am, but
Wait,
in
wait, wait,
my
wait. 1 minute.
last session,
that's not a balanced one though.
No, they have
For
not
black,
mentioned about balance. They have just mentioned it cross play laminate.
I think the first option should be correct, but you cross check once. Okay, you check why A16 and A26 will be equal to 0.
Hmm.
Uh,
Okay, okay. Again, I'll
yeah, yeah,
check
yeah. It
on
will
this
be equal
one.
to 0 because A16 and A26 is equating the force with the your shear, right? So it is the extension of shear coupling. For 0 and 90, there won't be any shear. So that's why A16 and A26 will also be 0. Yes.
Okay, okay. In last assignment, ma'am, I have done everything correct. But wow, one question was we are not getting correct answer. Ma'am. I have tried with my friends also, but they are also getting the same answer. It's what I'm getting. But the option you have available was a different one.
Which question?
Can I share it, ma'am?
Okay.
Yeah, ma'am. One, two, three. Yeah, this third one, ma'am. This third one, as you see, we have also solved like left hand side or right hand side. Also have used to solve, ma'am. But also we are not getting this answer. This problem number three, ma'am. But
Hmm.
anyone, alpha one also we are not getting, ma'am.
Okay. Can you put it in the discussion forum so that sir can see that maybe there is some problem in the solution or
No,
something.
ma'am. I just no, ma'am. You check one more time, ma'am. If what is came again, same thing. I can drop in discussion.
No,
Sincerely,
if
it
you
is
have
correct.
done,
Then we can follow you, ma'am.
no, if you have solved it and you are getting different answer, that there might be a chance that the question is wrong. So it is better you put it in discussion. Then others can also get the help from there, right?
Okay, okay, ma'am. I will cover it. In this last term also, ma'am, I'm getting some different answers. Here I'm getting some solving issue on it.
So here you took the CF as equal to 0 and CM equal to 0.005.
Yes,
And still you are
yes,
not
ma'am.
getting
Yes,
answer.
yes, ma'am. Not getting answer. I'm getting very near, ma'am. It was like 0.08. Somewhere I have missed the calculator. Might be, ma'am. So in second
Uh,
also I am getting 0.47. But it was
yeah, it
comes
is
up
very close, but
1.52. 0.5. But okay, ma'am. In discussion, I have asked sir about the term on this question, ma'am. Problem three.
yes. If you have solved and your friend also getting different answer, then there might be a chance question has a problem. So you can ask, sir. Other students will also be
Okay,
helpful with that. No?
okay, okay, ma'am.
So do you have any more doubts?
No, 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 ma'am. No, I will leave, ma'am.
Okay.
Thank you so much, ma'am.